Magandang araw! Narito kayo ngayon upang malaman kung ano nga ba ang mga tatalakayin sa ikalawang markahan ng Matematika Baitang 10. Kaya tara na at samahan kaming matuto.
What to learn and expect in mathematics for grade 10, quarter 2.
Number 1, polynomial function. Number 2, circle and related terms. Number 3, secants, tangents, segments and sectors of a circle. Number 4, using the distance formula, improving geometric properties. Number 5, center radius, form of the equation.
Polynomial function.
What is polynomial function? A polynomial function is a function that involves only non-negative integer powers or only positive integer exponents of a variable in an equation, like the quadratic equation, cubic equation, etc. For example, 2x plus 5 is a polynomial that has exponent equal to 1.
Usually, the polynomial equation is expressed in the form of a sub n, x sub n. Here a is the coefficient, x is the variable, and n is the exponent.
So, let's talk about the anatomy of polynomial function, where a sub n called the leading coefficient and these two called the leading term and the other terms called by their degree or exponent. So, if it's 3, we call it cubic term. If it's 2, we call it quadratic term. If it's 1, we call it linear. If it's 0, we call it as constant term. The type of polynomial function is constant if the degree is 0. For example, fx equal to negative 14. The type of polynomial function is linear if the degree is 1. For example, fx equal to 5x minus 7. The type of polynomial function is quadratic if the degree is 2. For example, fx equal to 2x squared plus x minus 9. The type of polynomial function is cubic if the degree is 3. For example, fx is equal to x cubed minus x squared minus 3x. And last, the quartic. The degree of quartic is 4. For example, fx equal to x raised to 4th power plus 2x minus 1. Some of the examples of polynomial functions are here. X squared plus 2x plus 1, 3x minus 7, 7x cubed plus x squared minus 2.
Number 1. The graph of any type of function must pass the vertical line test.
Number 2. Every polynomial function with real coefficients has the set of real numbers as its domain, hence it is continuous function. This means that the graph of a polynomial function does not break holes or gaps. Number 3. A polynomial equation of the nth degree cannot have more than n roots. This only means that the graph cannot intersect the x-axis more than n times.
Number 4. A graph of a polynomial function has only smooth, rounded turns. A polynomial function cannot have a sharp turn. As we can see on the left side, we have an example of graph of px. On the other side, this is not the graph of px. Zeros of polynomial function. The rational zero theorem help us to narrow down the list of possible rational zeros for polynomial functions. For example, find the zeros of fx equals 4x cubed minus 3x minus 1. The rational zero theorem tells us that if p over q is a zero of fx, then p is a factor of 1 and q is a factor of 4. For example, p equals to factor of constant term over q, factor of leading coefficient, equals factor of negative 1 over factor of 4. The factors of negative 1 are positive negative 1, and the factors of 4 are positive negative 1, positive negative 2, and positive negative 4. The possible values for p over q are positive negative 1, positive negative 1/2, and positive negative 1/4. These are the possible rational zeros for the function. We will use synthetic division to evaluate each possible zero until we find that gives us a remainder of 0. Dividing by x minus 1 gives us a remainder of 0. So 1 is a zero of the function. The polynomial can be written as x minus 1 times 4x cubed plus 4x plus 1. The quadratic is a perfect square. Fx can be written as x minus 1 times 2x plus 1 squared. We already know that 1 is a zero. The other zero will have a multiplicity of 2 because the factor is squared. To find the other zero, we can set the factor equal to 0. For example, 2x plus 1 equals 0. So here, the x is equals to negative 1/2. The zeros of the functions are 1 and negative 1/2 with multiplicity of 2. Look at the graph of the function. Notice at x equals negative 0.5, the graph bounces of the x-axis indicating the even multiplicity 2, 4, 6 for the 0, negative 0.5 at x equals 1. The graph crosses the x-axis indicating the odd multiplicity 1, 3, 5 for the 0, x equals 1.
Multiplicity sub 0. The multiplicity of a0 is the number of times the real root of a polynomial function's result in fx is equal to 0.
Solve for the zeros of fx equals x squared times x minus 2 squared. X squared times x minus 2 squared equals 0. By zero product property, x squared equals 0 or x minus 2 squared equals 0. X squared equals 0, therefore x equals 0 to the multiplicity of 2. X minus 2 squared equals 0, therefore x equals 2 to the multiplicity of 2. The exponent tells us the multiplicity. The graph of the polynomial function fx equals x squared times x minus 2 squared, as shown at the right, is tangent to the x-axis at points 0, 0, and 2, 0.
Behavior of polynomial function.
The behavior of the graph of a function to the far left and far right is called end behavior. Although the graph of a polynomial function may have intervals where it increases or decreases, the graph will eventually rise or fall without bound as it moves far to the left or far to the right.
Circle and related terms.
What is a circle? A circle is a set of points on a given plane which is equidistant from fixed point called a center.
So this is what a circle looks like.
The central angle intercepted arc. A central angle is an angle whose vertex is the center whose side contain two radii. The measure of a central angle of a circle is equal to the measure of its intercepted arc. Measure of angle BEA is equal to measure of intercepted arc AB. The arc addition. The measure of the arc formed by the two adjacent arcs is the sum of the measure of the two arcs.
Measurement of arc ABC is equal to measurement of arc AB plus measurement of arc BC.
Inscribed angle and its intercepted arc. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. The arc that lies in the interior of inscribed angle and has endpoints on the angle is called intercepted arc. The measure of inscribed angle is equal to 1/2 of intercepted arc. Since angle PEO is a central angle, measure of angle PEO equals measure of arc PO. Measure of angle PHO equals 1/2 times measure of angle PEO. Measure of angle PHO equals 1/2 times 80, and the final answer is measure of angle PHO is equals to 40.
Theorems related to the chords arcs, central angles, and inscribed angles. In a circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. In a circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. In a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. If a quadrilateral is inscribed in the circle, then its opposite angles are supplementary.
Theorems on angles formed by tangents, secants, and chords. The tangent-secant theorem. Given an angle with its vertex on a circle, formed by a secant ray and tangent ray, the measure of the angle is half the measure of the intercepted. Number 6. If the chords intersect within a circle, then the measure of the angle formed is equal to the half the sum of the measure of the intercepted arcs.
Number 7. If a tangent and a secant, two secants or two tangents intersect in a point in the exterior of a circle, then the measure of the angle formed is equal to 1/2 the difference of the measures of the intersected arcs.
Secants, tangents, segments, and sectors of a circle. Sector of a circle. A sector of a circle is the region bounded by two radius and their intercepted arc. To find the area of the sector of a circle, get the product of the ratio and the area of the circle. Formula: area of sector, pi r squared, central angle over 360, where c is the central angle and degrees r is the radius of the circle. Pi is pi, approximately 3.14. Here we have sector ABC.
Example, find the arc of the sector of radius 6 centimeters and its central angle is 70 degrees. Note that the measure of the central angle is equal to its intercepted arc. Solution: area of the sector is equal to pi r squared times c over 360. When we distribute the given example, it will become 3.14 times 6 squared times 70 over 360 square inches is equals to 21.99 centimeters.
Segment of a circle. A segment of a circle is the region bounded by an arc and its chord. To find the area of the shaded segment, subtract the area of a triangle from the area of a sector.
Area of the segment is equal to area of the sector minus area of the triangle. Area of the segment is equal to pi r squared c over 360 minus 1/2 r squared sin c. Area of the segment is equal to 3.14 times 8 squared times 60 over 360 minus 1/2 8 squared sin 60 is equal to 5.78 square meters. Arc length. The length of an arc can be determined by using the proportion. Arc length is equal to measure of the central angle over 360 is equal to 2 times 3.14 times 6 is equal to 9.42 centimeters. In the given proportion, 360 is the degree measure of the whole circle while 2 pi r is the circumference.
If angle BEA equals 90 degree and the radius is 6 cm, what is the length of arc intercepted by an angle? Arc length. Measure of the central angle over 360 times 2 quantity of 3.14 quantity of 6 is equal to 9.42 cm. Theorems on secant and tangent segments of a circle.
Theorem on two intersecting chords. If two chords of a circle intersect, the product of the measure of the segment of the other chord is equal to the product of the measures of the segments of the other chord.
Theorem on two secant segments. If two secant segments are drawn to a circle from an exterior point, then the product of the lengths of one secant segment and its external secant segment is equal to the product of the lengths of the other secant segment and its external secant segment.
Theorem on two secant segments. If two secant segments are drawn to a circle from an exterior point, then the product of the lengths of one secant segment and its external secant segment is equal to the product of the lengths of the other secant segment and its external secant segment.
Using the distance formula and proving geometry properties.
Example, find the distance between the points with coordinates negative 3, 4, and negative 5, 2. Using the distance formula, we get distance is equal to the square root of x squared minus x raised to 1 times squared plus y raised to 2 is equal to y raised to 1 times squared is equal square root of 5 minus times negative 3 squared plus negative 2 minus 4 squared, and it is equal to square root of 8 squared plus negative 6 squared, and that is equals to square root of 100, and the square root of 100 is 10.
Find the distance between the points with coordinates 3, 4, and 0, 0. Using the distance formula, we have d equals square root of x squared plus y squared equals square root of 3 squared plus 4 squared equals square root of 25 equals 5.
Many geometric properties can be proven by using a coordinate plane. A proof that uses figures in a coordinate plane to prove geometric properties is called a coordinate proof.
Number 2. Label the coordinates as shown below. AC is equal to the square root of A minus 0 squared plus B minus 0 squared. AC is equal to square root of A squared plus B squared.
Letter A. Find the distance between A and C given A 0, 0 and C A, B. BD equals square root of A minus 0 squared plus 0 minus B squared. BD equals square root of A squared plus B squared. Letter B. Find the distance between B and B. C. Given B 0, B and D A, 0. Example number 1. Write the question of the circle whose radius is 5 and the center is at the origin. X squared plus y squared equals r squared. X squared plus y squared equals 5 squared. X squared plus y squared equals 25. Write an equation of a circle with center at the origin. Substitute 5 for r. Simplify. An equation of the circle is x squared plus y squared equals 25.
Center. Radius form of the equation of the circle. In the coordinate plane, the center radius form of the equation of the circle with center at h and k and radius are x coordinate of x minus h squared plus y minus k squared is equal to y coordinate of y squared. Example 2. Use the center radius form x minus h squared plus y plus k squared is equal to r squared. Substitute the h as x coordinate of the center and k as y coordinate of the center and the value of radius. X plus 5 squared plus y minus 3 squared is equal to 12 squared.
Example 3. For the equation x minus 2 squared plus y minus 1 squared is equal to 5 squared, where the center is h is equal to 2 and k is equal to 1, These are the coordinates of the center point 2 and 1. Remember, if h and k are confusing, the number with x is the coordinate, the number in parentheses with y is the y coordinate of the center. Example 4. Determine the coordinates of the center and radius of the given circle described by the equation x squared plus y squared minus 4x minus 8y minus 5 is equal to 0. Solution. The equation of the circle x squared plus y squared minus 4x minus 8y minus 5 is equal to 0 is written in general form. To determine its center and radius, write the equation in standard form. X minus h squared plus y minus k squared equal to r squared.
So that is all about the topic of quarter 2 mathematics. Thanks for listening. Until we meet again. Thank you.